The topic of our final year project is Partial Replacement of E-Plastic Waste as a Coarse Aggregate in Concrete, Department of Civil Engineering, CUI-WA.
Group members working on this project are Syed Muzammil Ahmed Bukhari, roll number FA19CV047, Abdullah Aftab, roll number FA19CV035, Malik Muhammad Talha, roll number FA19CV054. This project is supervised by Mr. Raja Muhammad Tasaduk.
The scheme of this project is as following. Introduction, problem statement, aims and objectives, methodology, materials, material properties, experimental plan, mix design, sample preparation, results and discussion, conclusion, future recommendation.
Introduction. Concrete is the basic engineering material used in most of civil engineering structures. E-plastic waste management and recycling is quickly expanding since it is a lucrative resource for IT businesses, as well as a very toxic product with a low recycling rate. Utilization of e-plastic waste is the partial solution to environmental and ecological problems. This waste consists of discarded old computers, TVs, radios, etc. These plastics are non-biodegradable plastic wastes and used as partial replacement of coarse aggregate.
The real problem that this project will be dealing is that traditional concrete production heavily relies on the extraction of natural coarse aggregate, leading to environmental degradation and depletion of finite resources. Moreover, the improper disposal of plastic waste poses a significant challenge to sustainable waste management. Therefore, there is a critical need to explore alternative solutions that address both the environmental impact of coarse aggregate extraction and the management of plastic waste. This project aims to investigate the feasibility and performance of replacing traditional coarse aggregate with e-plastic waste in concrete, offering a sustainable and innovative approach to construction materials.
Aims and objectives. Aim. The prime aim of this project is to produce environmental-friendly, cheap, and lightweight concrete. Objective. The main objectives of current research are use of e-plastic waste as a partial replacement of coarse aggregate in concrete, evaluation of the mechanical properties of concrete containing e-waste, which are compressive strength, split tensile strength, flexural strength.
The methodology of the project is carried out in following steps: material collection, sample preparation, curing of sample, testing of sample, result and analysis.
Materials to be used in this project are Fauji cement, sand, e-plastic waste, natural coarse aggregate, water.
Now talking about the properties of material being used. Let's start by Fauji cement. Following are the properties of Fauji cement. Following are the properties of e-plastic. Following are the properties of natural coarse aggregate.
The experimental plan is: e-plastic waste is collected from the local vendor in Rawalpindi. After that, it is then shredded into pieces by a crushing machine so that it can use in replacement of coarse aggregate in concrete. The ratio used in the study is 1:4 and water cement ratio is 0.5. Concrete mixes were produced by replacing 0, 25, 50 and 75% as coarse replacement. Cylinders and beams were casted for compressive, tensile and flexural strength determined at 7 and 28 days.
Mix design. Concrete mixes were prepared by using e-plastic as partial replacement of coarse aggregate ranges from 0 to 75% by volume. Following table shows the mix design by volume percentage.
The sample preparation was carried out in following steps: sampling, mixing, oiling, casting, curing.
Discussing about the result of compressive strength. There is a graph given which represents the compressive strength of concrete having different proportion of e-plastic waste after 7 and 28 days.
Similarly, this graph represents the split tensile strength after 7 and 28 days.
And this graph represents the flexural strength of beams made by different proportion concrete after 7 and 28 days.
According to results, it can be noted that as the proportion of e-plastic waste increases in the concrete, its compressive, tensile, and flexural strength decreases.
Thank you very much for your precious time.